Another interesting case that happens diagrammatically with controlled operations is the controlled Z-gate. So let's look at an example of the controlled Z-gate. I'm going to use our definition and say that this is projector onto the 0 state, tensor identity, plus projector onto the 1 state, tensor Z. So that's just our definition. And then we could work out what this is as a 4x4 matrix. So it would be identity Z, as we just discussed using this result. And so as a 4x4 matrix, that's identity is 1, 1, and then Z is 1 minus 1. So a 4x4 diagonal matrix, all ones, but the sign of the last one is negative instead of positive. So as an exercise, actually, you'll do this one on your next homework too, and I'll leave it to you there. You'll show that the controlled Z operation is actually equal to flipping the control on the target. And so for this reason, we use a symmetric notation where it's just a control on either qubit line. So this one isn't too hard to show, by any means. Just use the definition and show that you get the same thing. And I just wanted to write it down to say the notation and give justification for that. It's symmetric with respect to control and target, and so it's good to have a notation that respects that. And when we write down CZ in circuits, this is the notation that we'll use.